Hello everyone, welcome back to this online class. Today we are going to look at numerical solution of ordinary differential equations, and in particular we are going to look at Runge-Kutta fourth order method. Now we have this question. We are asked to use Runge-Kutta fourth order method to solve the initial value problem given by dy over dx is equals to 2x plus y, subject to the condition that y of 0 is equals to 1, with h is equals to 0.1. Estimate the value of y of 0.1, y of 0.2, and y of 0.3 correct to 6 decimal places. So let's see how to go about this problem. Remember, we have to start from the iterative formula. But before I look at the iterative formula, let's look at our ODE. dy dx is equals to 2x plus y. The 2x plus y here is our f of xy. The initial condition at 0, that is our x naught, and 1 here is our y naught. So you can write here that x naught is equals to 0, y naught is equals to 1. We know h is equals to 0.1, and f of xy is equals to 2x plus y. So remember the iterative formula for the Runge-Kutta fourth order method, that to get yn plus 1, it is equals to yn plus k. Of course, for n is equals to 0, 1, 2, 3, etc. Now, how do we calculate k? Where k, and just write here where, k is given by 1 over 6 into k1 plus 2k2 plus 2k3 and then plus k4. It's just the average, k1 plus k2 plus k2 plus k3 plus k3 plus k4. We are averaging 6 items, and that's why we are dividing that by 6. Now, how do we calculate k1 all the way up to k4? K1 is given by h times f of xn, yn. K2 is equals to h f of xn plus h over 2, comma, yn plus k1 over 2. K3 is equals to h f of xn plus h over 2, comma, yn plus k2 over 2. And finally, k4 is equals to h f of xn plus h yn plus k3. So this is the iterative formula for the Runge-Kutta fourth order method. This iterative formula can be represented as what we are calling a Bacha table. Let me show you how to represent this as a Bacha table. So just to take note, that the budget table for this iterative formula is written as budget table. This is how the table will look like. We have a vertical line. I'm going to list the values. I'm going to tell you how to work it out, how to draw the table. Because you see, at times you might be given a budget table and you are asked to use Runge-Kutta fourth order method for that particular budget table. So when you look at the K1, K2, all the way up to K4, look at here. Xn, we are adding nothing. So I'm going to write here 0. Xn, we are adding 0. What about Yn? We are adding nothing. There's a blank there, a blank space. So simply the coefficient of what we are adding is 0 and the other one is the blank space. Now look at K1. After Xn, we are adding 1 over 2h. So the coefficient is 1 over 2. You write here 1 over 2. And for the K1, what have we added? Yn plus 1 over 2 K1. So again, here is 1 over 2. Proceed. The blanks means you are adding nothing. Proceed to K3. Here again, we are adding 1 over 2h. So the coefficient is 1 over 2. And here we are adding 0. It's like 0 K1 plus 1 over 2 K2. So it's 0 for K1. And for K2 is 1 over 2. And finally, for K4, the coefficient of h there is 1. What about the coefficient of K1? K1 is 0. 0 K1 plus 0 K2 plus 1 K3. So 0, 0, 1. And finally, for the formula, for the K, if I open the bracket here, I'm going to get 1 over 6 K1. So here we'll have 1 over 6. Then let me just write it here. It's 1 over 6 K1 plus 2 over 6, which is 1 over 3 K2 plus another 1 over 3 K3 plus 1 over 6 K4. So I'm going to write the coefficients. So the next is 1 over 3 followed by 1 over 3 and followed by 1 over 6. So this is what we are calling a Badger table. The blanks that you can see there, it means zeros, which I don't even need to write. So I'll even wrap this blank space here. There's nothing. So what it means here is that these are the coefficients of h. These other ones are the coefficients of K1. The next is K2. The other one is K3. And lastly, K4. This is what you are calling the Badger table. That was just a note because in some examples, you might be given the Badger table for the Runge-Kutta fourth order method or whichever order, and you are asked to use that table to solve any given initial value problem. Now let's go back to our problem. Now that we know the iterative formula, we are going to iterate from 0, 1, 2, 3, etc. But what are we asked to find? We are asked to find y of 0.1. So let me summarize this here. So we are given the initial condition that when x is 0, y is equals to 1. Now the steps are the 0.1. So from 0, we go to 0.1. So we have 0.1. Continue adding, we go to 0.2. Then lastly, 0.3. So this is our x0, x1, x2, x3. This is our y0. I don't know the value here, which I need to find. That is y1. I don't know this, that is y2. I don't know the value here, and that is y3. And so when we write y1 is y of 0.1, or simply y of x1. Let me write them here before we start the computation. When I write y1, it is y at x1, which is the same as y at 0.1. We need to find it. What is it equal to? That's a question mark. When we write y2, it is the same as y at x2, and our x2 is 0.2, so that's y at 0.2. We also need to know the value here. And when we write y3, is the same as y at x3, which is the same as y at 0.3. We also don't know that. We will find it later on. Remember, the step size h is the distance between the x values. So here we have h, 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 which is 0.1. So having discussed all those, let's now perform the iterations. We will start with n is equals to 0, then go to n is equals to 1 in that order. Remember, for the Bacha table, it was just, by the way, just to tell you how to come up with a Bacha table for any iterative formula. Now, the iterations. Let us put n is equals to 0. That means we'll now be talking of y. y1 is equals to y0 plus k. So I need to calculate k. And k depends on k1, k2, all the way up to k4. So our k1 is equals to h f of x0, y0. That's when n is 0. So this equals to h. Now remember that our f of xy, let me show you how to find that. Back to this. Our f of xy is equals to 2x plus y. So from here, you can be able to get f of x n y n, x n y n, it is equals to 2xn plus yn. So when I want f of x0, y0, I'll just put n0, so we'll have 2x0 plus y0. So that's what I'll write here. So h into 2x0 plus y0, and that should give us, our h is 0.1, to our x0 is 0, y0 is 1. Press this in your calculator, you need to get 0.1. Work out k2, that is h f of x0 plus h over 2, y0 plus k1 over 2. And this is the same as writing h twice of x0 plus h over 2 plus y0 plus k1 over 2. When you substitute the values, of course, you know the value of x0, y0, k1, h. This is what you need to get. Let me replace the values. So that will give us 0.1, which is h, into 2, 0 plus h over 2 that is 0.1 over 2, plus y naught is 1, plus k1 over 2, 0.1 over 2. Press this in your calculator. You need to get 0.115. Proceed. K3 is h f of x naught plus h over 2, y naught plus k2 over 2, which is the same as h twice of x naught plus h over 2 plus y naught plus k2 over 2. Substitute the values, that's 0.1 for h, twice of 0 plus 0.1 over 2. Our y naught is 1 plus k2 is 0.115 over 2. When you press in your calculator, you need to get 0.11575. 0.11575. And finally, K4 is equals to h f of x naught plus h y naught plus K3. This will give you h into twice of x naught plus h plus y naught plus K3. I don't need to substitute, you just substitute. I don't need to write everything. Substitute those values. That should be able to give you 0.131, 0.131, 575. So therefore, what is our K? You can say that therefore, our K is equals to 1 over 6 times K1, which is 0.1, plus twice K2, which is 0.115, plus twice K3, 0.11575, then plus K4, 0.131, 575. Press this in your calculator. You need to get 0.115, 513. And so with this, we can now get y1, because now we have everything. So our y1 is equals to, let me use another color. Our y1 is equals to y naught, which is 1, plus our k, which is 0.115513, and that is 1.11513. And what did you say is y1? That is the value of y when x is 0.1. So you can just bracket this, and you say this is the value of y when x is 0.1. So this is y of 0.1. That's the first iteration. Let's look at the other iteration. So you write put n is equals to 1. That will now give us y2. y2 is equals to y naught, not y naught, should now be y1 plus k. So find again k1, k2. Now for this case, the only difference is that now n is 1. The same computations. So we start with k1. For this case, it is h f of x1, y1. That is h into 2x1 plus y1. Substitute those values. You know y1. Already we have found y1 to be this value. That's what you replace. Let me just write here. H is 0.1. Twice our x1 is 0.1. And our y1 is 1.115513. When you press this in your calculator, you need to get 0.131551. 131551. Find K2. That will be H f of x1 plus H over 2, comma, y1 plus K1 over 2. And this is the same as H into twice x1 plus H over 2 plus y1 plus k1 over 2. So you substitute those values, and when you press in your calculator, you need to get k2 is equals to 0.148129. 148129. Let's find k3. From the definition, it is h f of x1 plus h over 2, comma, y1 plus k2 over 2. And so, based on the definition of f of xy, this will give us h twice of x1 plus h over 2 plus y1 plus k2 over 2. When you substitute those values and you place in your calculator, you need to get k3 is equals to 0.148958. 148958. And lastly, k4, from our definition, it is h f of x1 plus h, comma, y1 plus k3. And so this should give us h. You see, our f of xy is 2x plus y. Where there is x, I'm putting x1 plus h. Where there is y, I'm putting y1 plus k3. So it will be twice of x1 plus h plus y1 plus k3. Substitute those values and then press in your calculator. You need to get k4 is 0.166447. 166447. So with these values, now we can find k. Let's compute k. So you can write here that therefore our k is equals to 1 over 6 into k1, that was 0.131551 plus twice of k2, 0.148129 plus twice of K3, 0.148958, then plus K4, 0.166447. When you press that in your calculator, you need to get the value of K to be 0.148, 0.148,695. And now you can be able to find K, Y2. Y2 is equals to Y1. Our Y1 was, we just use the value of Y1 that we found, 1.115115 plus K, which is 0.148,695. Press this in your calculator. That should give you 1.264 208. So this is the value of Y when X is 0.2. So we can comment on this again. And you say that this is the value of Y at 0.2, or simply Y of 0.2. Finally, we need to find Y when X is 0.3. So we have one more iteration. So we put N is equals to 2. So right here, put N is equals to 2. N is equals to 2. We are substituting into the iterative formula. So that will give us Y3 is equals to Y2 plus K. So let's compute K, but before we compute K, we need to know what is Y1 all the way up to Y4. Let's start by finding Y1. From our definition, not Y1, I mean K1 up to K4. So we compute K1. That should give us H times F. Remember now N is 2. It was F of Xn. So this should give us X2, comma Y2. And so based on our definition of F of Xy, which is 2x plus Y, in place of X we put X2, in place of Y we substitute Y2. So it will be 2x2 plus Y2. And so this is 0.1 times 2, twice of X2 is 0.2. And our Y2, we have just found it to be 1.264208. When you press this in your calculator, you need to get 0.166421. 0.166421. Let's get K2. That is H times F of X2 plus H over 2 Y2 plus K1 over 2. And this equals to H times twice of X2 plus H over 2 plus Y2 plus K1 over 2. you know the values of K1, H, X2, and Y2. If you substitute here and you plug in your calculator, you need to get the value of K2 to be 0.184. So we write 0.184,742. Let's find K3. That's equals to H, F of X2 plus H over 2, Y2 plus K2 over 2. And this equals to H into 2 times X2 plus H over 2 plus Y2 plus K2 over 2. Substitute the values of X2, Y2, H, and K2, and then press in your calculator to get the value of K3 as 0.185, 658. And finally, K4, that is H times F of X2 plus H, Y2 plus K3. Based on our definition of f of xy, that was 2x plus y. Where there is x, I'm going to substitute x2 plus h. And where there is y, I'm going to put y2 plus k3. So that is the same as h into 2 times x2 plus h plus y2 plus k3. Substitute the values of x2, y2, h, and k3 to get K4 is equals to 0.204 987. So with these values, we can now be able to find K. So you can say here that therefore, our K is equals to 1 over 6 times K1, which is 0.166421 plus twice of K2 is 0.184,742 plus twice of K3, 0.185,658, then plus K4, 0.204987. So when you press this in your calculator, you need to find the value of K as 0.185, 368. And finally, we can now compute Y3, which is Y2 plus K. Our Y2, we found it as 1.264208 plus the value of K, which we have found to be 0.185,368. Press this in your calculator. That will give you 1.449576. 1.449576. 9576. So this is the value of y when x is equals to 0.3. So let's comment on this one and write here that this is the value of y at x is equals to 0.3. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving numerical solution of ODEs. Bye-bye.